And then we have one more problem to solve is what if you have a categorical variable and you think that this categorical variable is very important to predict your response variable? But since we say the regression can only take care of the quantitative variable, that means we only can take care of the values, right? The categorical variable only contains the categories, right? So they are not the real values. That means the regression cannot take care of this kind of variable, right? So that means, for example, right, in the chapter notes, right here, I just list 3 examples. Right, the first one we say in the house price example, right, we say we have this variable which is called the fair places. Right. Okay, so actually for this variable, it just record how many fair places in this house, right? Either 0, that means no fair place in this house, right? 1, that means 1 fair place in this house. 2 means 2 fair places in this house, right? So actually, if you do the regression with this variable with either the number of bedrooms and the living area together so that you have a multiple regression with the 3 variables together, you will find that the p-value for this variable, the fair places, this variable is very large, right? So that means this variable doesn't provide the significant contribution to this multiple regression. Right, but actually it doesn't make sense because in our common sense, right, there should be a very significant difference between the house with the fair places, with the fair place, and without the fair place. There should be a big difference, right? So in this case, actually, I just changed this quantitative variable to a categorical variable. I just consider this house has the fair place or doesn't have any fair places. Right, so that's if I have 0, that means I just change to the category as no. If it is 1 or 2 or any value, then it will be yes. That means this house has the fair place. All right. Then we say if the number of fair places this variable was not collected as numbers, instead it was collected as either has the fair place or doesn't have the fair place, yes or no, then that means you have a categorical variable. Right, you have 2 categories in this categorical variable, right? So now we want to make a regression to see whether there is a significant difference between the house price with the fair place or without the fair places. Right, then what should we do? Right, so next example, we say we keep talking about the location of the house, right? So actually the location of the house is very important for the house price. So we say the house in the Ohio, of course, will be different with the price in California, in New York, right? So the location of the house is also a very important factor. But actually the location is a categorical variable, right? So if this variable is recorded as these 4 categories, right? East part, west part, the south part, and north part, right? Then this variable, this categorical variable has 4 categories, right? So how we can add this location, this categorical variable into our regression to make the prediction of the house price, right? Another example is this one always happen in the for banks, right? So if you are doing the regression for the bank predictions, right, the very important factor will be the card types, right? So you have the silver card, gold card, or platinum card will be making big difference with your predictions, right? But now you have the categorical variable. You have 3 categories in this in this variable card types, right? So actually, all of these three examples talk about important factors for predicting the response variable, but since they are categorical variables, we cannot just directly add them into the regression, right? The regression can only take care of the quantitative variable. So then we need to think about a way to assign the values to each categories. All right, then here we'll talk about the dummy variable. We will create a dummy variables. All right, and then since we do not have enough space in the chapter notes, I just create another one, right? Another empty file. All right, so then let me change my screen. All right, so let's talk about the dummy variable. Right, the dummy variable is also called an indicator. Right, so an indicator in the math class is actually short for I, right? So one variable is equals to 1 if some condition is satisfied, and if it is not satisfied, then it is equals to 0. Then this kind of variable is called the indicator. Right, so actually for this variable, you only have two values, either 0 or 1, right? If the situation is satisfied, then it equals to 1. If this situation is not satisfied, then this variable equals to 0, right? Then it is called an indicator. All right, so now let's still think about our example. Let's just use the location as our example. All right, so we say for the location, we have four categories, right? We have the north, we have south, we have west, we have east. Right, so we totally have these four categories, right? So normally, if uh, there is one categorical variable and then I ask you to assign some value to them so that we can make analysis to this categorical variable. You may think about, okay, I need to assign some value to each of these categories. Then what about assign 1 to north, 2 to south, 3 to west, 4 to east? All right, so does that work in our regression? Can we just assign these different values to each location? Right, so the problem here will be if you assign the values like this, that means the east is actually better than west, is better than south, is better than north. But actually it is not that case, right? So actually they are all equal locations. They should not be comparable. All right, so in this case, we need to think about a way to assign the values to them, but at the same time, they cannot be compared. Right, so actually they should be at the same level before you do any regression. All right, then we need to create a dummy variable, or we create dummy variables. Right, so now I will show you how to create these dummy variables. Right, so we say generally, if you have m categories for this categorical variable, all right, then what you need to do is you randomly choose one category as the baseline. For example, I randomly choose West as my baseline. All right, and then I will create a dummy variable for the north, one dummy variable for the south, one dummy variable for the east. That means totally I need to create m minus 1 dummy variables. right? So generally we say if you have this categorical variable has m categories, then you randomly choose one as the baseline. Then you need to create the dummy variables for all other categories. That will be totally m minus 1 dummy variables. Right, so in this case, how many dummy variables do we need to create? We need to create 3, right? Because we totally have 4 categories, right? So if we choose one as the baseline, the other 3 we need to use for the dummy variables. We need to create 3 dummy variables. All right, and then next, let's just talk about how we can create the dummy variables for each location, right? So for example, in our house price example, we have already got the number of bedrooms and the living area in our multiple regression, right? So we call this is x1, we can call this is x2. Right? And then we will generate or create another variable. We call it is x3. All right, and then this variable is for the location of north. Right, so this variable is created as an indicator variable. That means it's equals to 1 if the location is in north. All right, so if you have a house with the location in the north, then this variable x3 will be 1. That means if the location is not north, then this variable will have the value of 0. So that will be 0 otherwise. All right, so that will be the first variable. The second variable, we call it is x4, continuous. All right, so x4 is for the next category, which is the south. Right, so this x4 is for the is created for the south location. Similarly, we have it's equals to 1 if the location is south. If the house location is south, then this variable will be 1. And then we say if the location is not south, will be otherwise, will be 0. All right, and then we say we totally need to create 3 dummy variables. All right, so we create one for the north, one for the south, one will be the east, right? We use the west as the baseline. So then I have x5 equals to 1 if location is east and 0 otherwise. Right, so actually this is created for the east location. All right, and then if we set these 3 variables for the location with this way, then let's see the what will be the case. Right, so we say we create x3, x4, and x5. Right, x3 is for the north, x4 is for the south, x5 is for the east. All right, and then we say the location. If you have a house, the possible location for this house can be in the north, can be in the south, can be in the let's say in the east, and it is also possible to be in the west, right? So actually we have these 4 categories in the location variable. All right, so now think about one question. If the house is located in the north, then what is the value for x3? Anyone? If the house location is in the north, then what is the value for x3?
1.
1, right? Because this is how we define the x3, right? So if the location is in the north, then x3 will be 1. Perfect. Thank you. All right, what will be the value for x4? Mo, what do you think?
0.
0, right? Okay, what else? Next one, x5.
Also 0.
Also 0, right? So because x4 is set for the south, so since this location is not north, it is not south, it is north, right? So that will be 0 for x4 and 0 for x5. All right, so then if the location of the house is in the north, then you have one set of the values for x3, x4, x5, which is 1, 0, 0, 1, 0, 0, right? Okay, so next, what if the house location is south? Then what is the value for x3, x4, and x5? Alex, what do you think? Alex? Okay, maybe drunk from yesterday. Next one, um, Austin, are you there?
I'm here.
All right, perfect. Okay, so if the house has the location is the south, then what are the values for x3, x4, x5?
Um, are they all 0?
Right, so it would be 0 for x3 because the location is not north, right? Okay, what
Yeah.
about x4?
Would it be 1 then?
Would be 1, right? Because the location is south, right? So, okay, what about
And then
x5?
that would be 0.
It will be 0, right? Perfect. So that means if the house is located in the south, then you have another set of the values for x3, x4, x5, so which is 0, 1, 0. Thank you. All right. East. Any volunteer? Anyone? Um,
Well,
sure, go ahead. Yeah,
uh,
Johnny.
001.
0, 0, 1. Perfect. Good job. All right, so that will be for the east, right? So you have another set of values, right? The last one, okay, it's a little bit challenge. What about the location is west?
Would it be 0, 0, 0?
It would be 0, 0, 0, right? Perfect, right? So it is not north, not south, and also not east, right? So that will be for the west. Right, so if it is not north, not south, not east, that means this location is west, right? So this is why the west is called the baseline. All right, so now look at the set. We say we want to apply or assign some values into different categories to different categories, right? At the same time, we don't want them to be comparable. I don't want to see, okay, west is better than east, south is better than the north, right? So we want them at the same level. So now, if I create the variables like this, if I create these 3 variables like this, then I have 4 sets of values for each location, and you cannot say 100 is better than 010. It's not better than 001, 000, right? So they are just some values that you even cannot compare them. That is good. That is our goal, right? So then in this case, these 3 variables, right? These 3 variables, we call them the dummy variables. right? They are used to include the categorical variable location into our regression. Right? Got the idea? All right. Any questions? If you feel good, let's do 2 more examples. Right, so example 2. Right, so we talked about the fair place, right? So let's just use the fair place as the example, right? So we say fair place, I just change it to the categorical variable, either yes or no. Either has the fair place in the house or doesn't have any fair places in the house. All right, so now question. How many dummy variables do I need to create for this variable, for this categorical variable? And how you can set this or these categorical, these dummy variables.
I think you just need one, and then you set one as a baseline.
Right, so actually you only have 2 categories, right? Perfect, thank you. All right, so actually you have 2 categories. That means 2 minus 1. That means you have just 1 dummy variable. You only need to create 1 dummy variable. And then in this case, you can choose either one as your baseline, right? We say the baseline is just randomly chosen, right? It doesn't matter. It will not affect your result at all, right? So let's say if I choose no as the baseline, then how you can set your dummy variable? Let's say we need to create 1 variable, so it will be still x3, right? And now this 3 is for yes or for no. Joey,
For yes,
excuse me? Okay, Jake
It's for a yes.
is for yes, right? Perfect, right? So because the no is the baseline, right? So Jake, can you continue to tell me how you set this dummy variable? How you set this dummy variable? Jake, can you continue?
So it would be x3 equals 1
If
if fireplace equals yes.
right, right. So if this house has the fireplace, right? And then
Equals 0 if otherwise.
otherwise, perfect. Thank you. All right, so now we have this dummy variable, right, as the yes. All right, no as the baseline. And then actually we want to include this variable into our regression, right, so that we can use the regression to fit a regression equation for us. All right, so since we have the detailed data set, let's just go through this data set with the jump. Right, so this is the categorical variable. The fair place is either yes or no. All right, and then the jump can help you to create the dummy variables, the indicators. All right, and then we say once you choose this variable, you go to the columns in the top. All right, and then in the columns there is one option called the utilities. All right, and then in this option, there is one function called make indicator columns. All right, so if you choose this one, click OK. All right, then defaultly, the jump will create 2 indicator variables, right? So since you have 2 categories, then the jump will just create two indicators. But actually, remember, we only need one, right? The other one as the baseline, right? So it doesn't matter which one you use. We say, let's look at these values, right? So for example, the first house, right? This house, that means the fair place is this categorical variable. It shows no, right? So that means this house doesn't have any fair places. That means the no will equals to 1. Yes will be 0, right? If this house is yes, that means this house has some 1 or 2 or even more fair places, right? That means the no, this category will be 0, and then this variable will be 1. All right, so this is how the jump creates the indicator variables, but they are not the dummy variables yet. We need to choose one as the baseline. The other one will be our dummy variable, right? Okay, so then we say, we go to analyze, fit the model, right? And then the house price is still the Y, right? And then we can add the number of bedrooms, the living area into our regression, right? So this is x1, this is x2, something like that, right? And then for this fair place categorical variable, right, either yes or no, we have the indicator variables. Now, since in our practice, right, we chose the no as the baseline, that means we create a dummy variable for yes, right? So in this case, we can include the yes into our x or the explanatory variables. All right, and then since we have two categories, we need to only include one of them into the regression. All right, and then click run. All right, so now this is the default output, right? We have all of these plots. We have the residual plot, right? And then we have these three tables, right, for the multiple regression. All right, so now let me make a screenshot of our results, right? And then minimize that. All right, so now based on our output, we actually can use these estimates, right, to write out our regression equation, right? So we say we have y hat will equals to 21129.28. What is this? This is the intercept B0, right? And then minus 7216.5 for the bedrooms, right? So this is, we can call it is X1, right? So it is the number of bedrooms. All right. And then next one is for yes, right? So it will be 12949.606. All right, so actually you can call this is x2, it doesn't matter, right? So you can, this is as long as you have the notation, right? So it doesn't matter which one is for which, right? And then the last one you have 89.06 x3, which is for the living area. All right, so that means based on the outputs, we write our multiple regression equation, right? So let me yeah, okay. It's okay. Right. So that means we have these two quantitative variables, number of bedrooms and the living area. And then we have a categorical variable, one dummy variable for yes, right? So actually this variable is for the location. All right, so now think about the first question, how you interpret this B0. We say B0 is 21129.28. Based on this equation, right, how you can interpret this intercept. We say to interpret a intercept, that means the predicted y when all the explanatory variables are equals to 0, right? Okay. Not location. Why I write the location here? It's not the location, it's the fair place. All right. Anyone want to try? If no one want to try, let me ask someone. Marco. Marco?
Is that house price when all the other variables are zero?
Will be all these x's will be 0, right? So what does that mean? When x1 equals 0, that means
There's no bedrooms.
no bedrooms. Perfect. All right. What about x2?
There's no fireplace.
No fireplace. Perfect. Right. What about x3?
There's no living area.
Living area equals to 0, right? So if a house has no bedroom, no fireplaces, and living area is also 0, then we say the predicted house price will be 21129.28. Is that right? All right. Okay. Thank you, Marco. All right. So now it is about the intercept. Right now, what about this coefficient? We say this is B0, this is B1, this is B2. Right, so let's just choose B2, 12949.6. Okay, let's just do one by one, all right, not escape. All right, let's say how to interpret B1. What does this B1 mean? Say in the multiple regression, how you can interpret a coefficient before the each predictor. We say we need to fix the levels of other variables, right? And then we say the one we want to interpret will be when x increased by 1 unit, the y will increase by the coefficient. Right? So now let's do this as an example, right? So we say how we can interpret this negative 7,000 something. Then we say when we need to first fix other levels, right? So then that means we need to fix the fireplace and the living area, right? So that means when the fireplace and the living area are both fixed, right? Then each one more bedroom will decrease because it is negative, right? Decrease the house price by how much? About $7,000. All right, so that will be the way how you interpret B1. About B2. What about B2? what does B2 mean? We say the B2 is about the fair place, right? And then B2 is actually about this variable, right? Actually, this is a dummy variable. This is an indicator variable. It only has the value 0 and 1. If it has the fair place, then it will be 1. If there is no fair place, it will be 0. Then, what does the coefficient here mean? Anyone want to try? Johnny, you want to try?
I'm not quite sure. Is it when living area is fixed?
Mm-hmm.
If the
And also the number of bedrooms also fixed, right? So we
Okay.
need to fix all other variables, right?
So then,
there.
when both of those are fixed, the fireplace, every number of fireplaces that increase, the price increases by $12,949.
99% right, but actually it is not for every increase for x2 because x2 can only increase once, right? Can
Oh,
only
yeah.
increase from 0 to 1. So how you can say that?
So if
If the
when
house,
when the bedrooms and living area are fixed, if the fireplace increases by 1, then the price increases by that number, right? Or
so actually this is no fair place, right? This is yes, has the fair place, right?
Mhm.
So then let's say this way, and then you will find out why, right? So we say, again, we need to fix both of these two, right? So we say when the number of bedrooms and the living area both fixed, right? Then when x increase from 0 to 1, y will increase by this much, right? So that means what? That means when x increase to 1, that will be with the fair place, right? So then a house with the fair place will have higher price than the houses without the fair place. By how much? By this much. You see the difference? Right, so we say for the quantitative variable, x can always increase by 1, right? If x equals to 2, then you always can increase to 3. But for the dummy variable here, for this x2, the dummy variable, you can only increase from 0 to 1, right? So that means from no fair place change to with a fair place. Then what is the difference? That means it is positive, right? So that means the house price will increase by this much. In the other way, that means what? That means the house with a fair place will have a higher price than the houses without the fair place by how much? By this much. Got the idea? All right. Okay, so again, let's come back to our output. Right, so we say from the output, we got these estimates. We can also get their corresponding p-values. Right, so we say if I set my alpha to be 0.01, then that means this number of bedrooms, this yes, and the living area, all of these three variables are significant, right? They have significant contribution to the multiple regression. All right, so we know what does the number of bedrooms has the significant contribution to the multiple regression mean, right? We know what does that mean. We also know about the living area. We just say the living area, this variable make significant contribution to the multiple regression. But what does this yes mean? Right? What does this yes make the contribution, make the significant contribution to the regression? What does that mean? Can we change a way to interpret this result? We say if this variable is significant, actually this is a what? This is a dummy variable, right? So we create this dummy variable for the fair place, right? So that means if this is significant, that means this level is significant, right? So that means what? That means whether this house has a fair place or no fair place, it will make significant difference in what? In the house price. Right. So we say if this variable is significant, then there will be significant difference between either have the fair place and no fair place when we predict the house price. Got the idea? Right? Any questions for now? All right, so let's continue. We say we talked about the fair places, right? So actually this example is very kind of easy because we only have two categories. Right, so now let's make another example. What about the location? Right, the location of the house. We say for the location, we have four categories, right? So we have north, we have south, we have west, we have east, right? So as what we did in the example, we say we set the west as the baseline, right? So that we create three dummy variables, right? So with the number of bedrooms and living area in the regression, I create x3, x4, x5. Right, so x3 is for north, x4 is for south, x5 is for east because the west is the baseline. All right, and then x3 equals to 1 if the location is north, right, equals to 0 otherwise, right, I just write it for short. Right, the other one for x4 we say it equals to 1 if the location is south, equals to 0 otherwise. Right, and then for x5 it equals to 1 if the location is in the east, right, equals to 0 otherwise. Right, so actually this is the way how we create these three dummy variables. All right, okay, so now with these three dummy variables, actually all of these three variables is to describe the location, describe this categorical variable. All right, okay, now the same thing. Once we have these variable, this location variable, we have the locations of each house, right? And then we can ask the jump to create indicator columns, right? And then we can fit the model. We add the price as the Y, we add the number of bedrooms, living area into the X part. And then we also pull the x3, x4, x5, which is for north, for south, for east, into that space also, right? So that you will have a output, right? Suppose you have a output as y hat equals to 17429 minus 7616 x1 plus 94x2 plus 4548 x3 plus 7261 x4 and then plus 2809 x5. Right, so again, this x1 is number of bedrooms. This x2 is the living area. x3 is for north. x4 is for south. x5 is for east, right? So we know these three are for the location. All right, okay. So now, if based on the jump, you have this multiple regression equation, then again, one more question, how you interpret this B0? 17249. Anyone want to try? The intercept, 17249. Nico, you want to try? Nico, are you there?
Yeah, I'm here.
When we interpret the intercept, that means all the x variables will be 0, right?
Oh, so of this equation, I think the intercept would be 17 to 49 there.
Right, so how you can interpret this one? What does that mean?
Okay, so when all of the variables that affect this are 0.
More details. That
So
means when
when
x1 equals 0, that means
yeah,
what?
so that means there's no bedrooms in the
Okay,
house.
no bedrooms. Perfect. All right, continue.
And when the house has no living area.
Okay,
and
no
when the
living
house-
area.
And when the house doesn't have any of the other things.
Yes, think about it. What will be the location for the house if it is x3 is 0, x4 is also 0, x5 is also 0. Then where is your house? X3 equals 0. That means the house is not in the north, right? Not
so
in the south, not in the east. So where is your house?
In the west?
In the west, right? Perfect, right? And located in the west. All right, then what we say?
Then we'll say that if those all are true, then the price is going to be 17 to 49.
Perfect. Good job. Thank you, Nico. Right, so that we say the predicted price would be 17249, right? So again, we also need to write one more sentence, right? We say what? We say this interpretation about the intercept doesn't make sense in our real life, or we say this interpretation doesn't have a practical meaning, right? Because this house, any house cannot have just no bedrooms, no living area, right? Okay, so this is B0. Good job. All right, next one, B1. Negative 7616. Interpretation of B1. What does that mean? Pranav, you want to try?
Will it be when the living sorry 7616 when the number of bedrooms increased by 1, the price decreased by 7616?
Almost there. we say since this is the multiple regression, what do we need to do first?
The other factors are fixed.
Right. So can you repeat that again?
So when the living area is fixed and the location is fixed,
Okay, if both of these two are fixed, and then what?
then when the number of bedrooms increases by 1, the price decreases by 7616.
Perfect. Good job. Thank you. Right, so we say when both of these two are fixed, then if you have one more bedroom, the house price will be decreased by 7,000 something, right? So $7,616. All right, good job. All right, and then we say B2 will be similar, right? B2 will be when the number of bedrooms and the location of the house are both fixed. Then if you have one more square foot of the living area, the house price will be increased by $94, right? So that will be B1, B2. So this is B0, this is B1, this is B2. Now next, B3. What about this 4,548? What does that mean? Any volunteer? Oh, a little bit tricky, so any volunteer?
So when everything else is fixed,
Okay,
in the north will be $4,548 more expensive than a house that isn't in the north.
perfect. Good job. All right, so you got the point. Thank you, Mo. All right, so we say, again, we need to fix other levels, right? So we say when the number of bedrooms and the living area, right? When both of these two are fixed, then what does this mean? So actually we say when x3 increase from 0 to 1, that means 0 will be not in the north, right? And 1 means the location is in the north, right? So that means what? That means the house price for the north houses will be, since it is positive, right? So it will be higher than non-north houses by how much? By $4,548. All right, so you got the idea now? We say for this indicator variable, it can only take 0 and 1. So that means if it is 0, it will be gone for this term. If it is 1, that would be just a 4,548, right? So that would be when x increase from 0 to 1. That means when the location of the house changed from non-north to the north location, then the house price will be increased by this much, right? So, or you can just change your language. It doesn't matter what kind of language you use, as long as you can explain what does that mean, right? So you compare the house price for the houses in the north and the houses not in the north, right? The difference will be this much. All right, so the other coefficients will be similar, right? So this one will be in the south and not in the south, right? The difference will be 7 to 61, right? In the south will be more expensive than not in the south, right? This one will be in the east, right? So 2809, that would be the houses in the east will be higher than the houses not in the east by this much. All right, Okay, so now you got the meanings for all of these coefficients, right? Okay, and then one more question. One more question. We say, let me write down the equation again so that you don't need to go up, right? So y hat equals to 174,249,161,661 plus 94x2 plus 8x3 plus 261x4 plus 2809x5. Right, so again, this is for north, this is for south, this is for east, right? This is for living area, this is for number of bedrooms. All right, so now one more question. We say I have two houses, right? House one. House one is located in the north, right? House two is located in the south. All right, and then I know that both of these houses has the same number of bedrooms, the same living area. The only difference between these two houses is one is located in the north, the other one is located in the south. Now, my question is, which house price should be higher? Higher by how much? Think about it. Yes, Johnny?
Is it south?
Excuse me?
Is
South.
it? Yeah.
All right, south is higher. Okay, that's right. All right, what will be the difference?
The difference will be 2,713.
Perfect. Good job. All right. Okay, so if you don't know how to get that 2,713, something like that, all right, let's just try one by one, right? So we say for house one in the north, what will be the equation changed to? If the house one in the north, that will be x3 will be 1. The other two variables will be both zeros, right? So that means the equation will change to 17249 minus 7616 x1 plus 94 x2, and now x3 changed to 1, right? So it will be just a 4548. All right, so that would be for house one. What about house two? House two is in the south, right? Okay, so that means what? That means the south variable, this one, x4 will be 1. The other ones will be all zeros. All right, so then what will be our equation? Will be the same 249 minus 7616 x1 plus 94 x2. But now this term is gone, this term is gone, this one x4 is 1. So that will be just a plus 7261. All right, so now who is better? Who is higher? We say they have the same number of bedrooms, they have the same living area, and then which one is higher? Of course, house 2 is higher, right? How higher by how much? 7261 minus 4548, and then you can get it as 2713. Will be, that means the house 2 in the south is higher than house 1 in the north by $2,713. All right, so that means once we have the dummy variables, we can fit this regression equation, and then based on this equation, we just can compare for every location, right? So actually we can kind of know how much will be the difference between the two locations of the houses. All right, and then the last topic, right? So it will be again, we say Okay, so we say if from the output, right? So in the parameter estimates table, we say the p-value, the last column for the p-values, right? So let's say for x3, x4, x5, which is for the north, south, and east. Right, so then I got the p-value, and for the north is less than 0.0001. For x4 is 0.2561. And for the east, I got the p-value is 0.006. Okay, so now, what does this mean? What does this p-value mean? Xingyao, are you there? Xingyao. Okay. Okay, good.
What is the question? Can you repeat again?
Sure. We say from the parameter estimates table, we got the p-values, right? So we got the p-value for each variable, right? So now I get the p-value for the x3 is less than 0.001. So what does that mean? What is your conclusion?
Okay. So for the conclusion, like, it's smaller than the alpha. It's too small.
It's too small. It's less than any common used alpha, right?
Yeah. So
Okay.
we reject the null hypothesis.
Hypothesis, all right. And then, what is your conclusion?
Like,
We say this variable make significant contribution to the regression. Is that right?
yeah.
Okay, now more deeply, what does this variable, this x3 variable, make the significant contribution to the model? What does this mean? What does this conclusion tell you? This x3 is for the north, right? For the location of north. That means x3 only have two values, whether the location is north and not north, right? So either has the location in the north or the location is not in the north, right? For the x3. So that means what? That means there is significant difference for the house price that's in the north or not in the north. Between the north and not in the north, there is a significant difference in the house price. Got idea? Xingyao? Any question you want me to repeat again? Hello?
Wait, I just don't get it. Like,
Got it? All right. Okay, so let's say we say if the p-value is less than alpha, right? So that means you reject the null hypothesis. That means you have enough evidence to support that this variable, x3 variable, it has the significant contribution to the multiple regression,
yeah.
right? Okay, so this is the general conclusion. But now think about what does that mean? X3 means we created for the north, right? So actually X3 is a indicator variable. X3 equals to 1 if the location is north, equals to 0. Otherwise, that means not in the north.
Yeah.
Right? Okay, so now that means this variable make significant contribution to the regression. That means the regression is always to predict the house price, right? So that means this variable make significant contribution to the house price, predicting the house price. In what way? In comparing these two. right?
Yeah.
So that means if your p-value is less than alpha, that means this variable is significant in predicting the house price. That means there will be a significant difference between the house location in the north and the house location is not in the north. There will be a significant difference between these two.
Okay.
Got it?
Got it.
Okay, perfect. All right. And then let's try the second one. Okay, now this p-value is too large, right? It is very large. Of course, it will be larger than any common used alpha. Right, so now what is your conclusion? Any volunteer? If not, Francisca, you want to try? Francisca. Okay. How many of you got drunk yesterday? Anyone? I saw a lot of crazy parties beside my house. All right, Thomas, you want to try? Thomas? So if the p-value is 0.2561, what will be your conclusion?
Would that be larger than alpha?
Yes. And then
So we would reject.
we
Or
will
fail to reject.
fail to
Fail.
reject. Okay. And then
I'm not sure
then
what the next step is.
okay, then that means this variable doesn't have significant contribution to the model, right? That means since this x4 is set for the south, that means either the location is in the south or the house is not in the south, doesn't make any significant difference. Is that right?
Yeah.
No significant difference. If your p-value is too large, that means since there's no significant difference, that means this variable doesn't have any contribution to our regression. Got idea? All right, so similarly to x5, it's the same. This p-value is small, it's less than alpha. So that means there is a significant difference between the east houses and non-east houses. All right, okay. So I think that will be all for the dummy variables. All right, and then I have one more thing to talk about is about building the models. Right, so we say before we go through use the jump to fit the models, right? We always need to write the models out, right? So in our case, in the location example, we actually need to know that, okay, I want to include the number of bedrooms, living area into my regression, right? And now I'll have a location, and this location has 4 categories. That means I need to create 3 dummy variables. That means I need to continue beta 3 for one, and beta 4 for another one, and then beta 5 for another one, right? That means these 3 will be created for location. This one is for living area. This for the bedrooms, right? So actually this model should be stated before we do any before we do the analysis, before we want to add the location into our regression to get the detailed equations. All right, and then about state the models, in the essay assignment 6, right, the last question is asking you a separate question telling you that, okay, if it shows that the x1 shows the quadratic trend with the response variable, then what will be the model, right? So here I just want to talk a little bit, right? You will learn this in the future, but now I just say, we say since it shows nonlinear relationship, then we want to do the transformation, right? So we say we can do the natural log transformation. We can do the natural log of x. We can do the exponential transformation. We can do the squared transformation. We can do the square root transformation. All right, so then in this case, we say for the natural log and the exponential, you can directly add into your model so that you have mu of y equals to beta 0 plus beta 1 x1, for example, and then now you did a transformation to x2, then you can do beta 2 of times the natural log of x, right? So you can directly just plug in the transformed x into the model, right? Or you can use the exponential of the x, right? But if you do this nonlinear relationship is a quadratic relationship, right? Squared relationship, then you always need to, for example, you have this one as x1, right? So that's you want to add the x1 square in this model. Then the first you need to add the x1 itself into the model, and then you can add the square term into the model. Right, so that you have beta 1 x1 plus beta 2 for x1 squared. Right, if you have another one has the linear relationship with y, you can add beta 3 with x2. Right, if you have another one with quadratic relationship again, that means beta 4 x3 and then plus beta 4 x3 squared. So that means whenever you want to add a square term into the model, you always need to add itself first. Right, and another kind is, so just like in our example, we say the number of bedrooms and living area. Actually, these two are highly related. Right, so in this case, you can also try the interaction term x1 times x2. And then you can add this interaction term into the model so that you have mu of y equals to beta 0 plus beta 1. Remember, you always need to include itself into the model first, right? So it will be beta 1 x1 plus beta 2 x2. And then now you can include the interaction term. So that's, we can call it is beta 3 x1 times x2. So this is the way how you add the interaction term into the regression. All right, so you may have this kind of problem in the MyStatlab homework in the previous one, in the previous homework or in the practice, right? So just as long as you got the idea, it will be okay. All right, the next 5 minutes, I don't have time for introducing the project 2, right? And we'll just talk about project 2 in the next Wednesday. Right, so now I think it will be very necessary to talk about your exam 2 preparations. So next exam, right, next exam 2 will be on next Friday. All right, so next Friday will be your exam 2.